All right, evaluating functions. So this is probably your first introduction to function notation. So when we see this thing here, this f parentheses x close parentheses, how we pronounce this? So we pronounce it f of x. So like the entire year, you're going to hear people pronouncing it f of x, or if it's a g of x, or k of x, or it could be even like, it could even be f of b or f of c. Like it doesn't matter, letters are in there. But that's how you would pronounce it. And that inside that parentheses, kind of how the notation works, that's our input. That's our input. This is our input. So we plug in a number for x per se. And then when you evaluate it out, that's what gives you the output of f of x. Okay. So let me show you kind of how this works. Okay. So number one says evaluate the given functions given the input value. So A says g of 12. So that means I'm going to be using obviously the g. Whoops. That means I'm going to be using the g function. So g of 12. All that means is that I'm going to be plugging in. I'm going to be substituting 12. Let me write that in red. 12 in for x. That's what that means. I'm going to be substituting 12. So g of 12. That's my input. My input is 12. So I'm inputting 12 for x, and then I'm just going to evaluate it. So the 12 minus 3 is 9. The square root of 9 we know is 3. 4 times 3 is 12. And 12 plus 1 is 13. So that means g of 12, maybe I'll write that down here. G of 12 equals 13. That's what we just solved for. So h of negative 2, obviously we'll be using the h equation. So I'm going to put in negative 2 there. So these are absolute value bars. Hopefully you remember what those are. So I put negative 2 in there. Negative 2 minus 5 is negative 7. Now, hopefully you remember what absolute value means. Absolute value of negative 7 is positive 7. Remember, the absolute value is just the distance the number is away from 0, when distances are always represented as positive numbers. So absolute value of negative 7 turns into positive 7. And 7 plus 1 is 8. So that's it. H of negative 2 is 8. So, I mean, you can write h of negative 2 here if you want. But that's equals 8. So f of negative 3. So we'll be using the f function. So I'm going to substitute negative 3 in for x. Let's see here. Okay. So remember, we're just doing order of operations with all these problems, basically. So negative 3 to the second power is 9. I'm going to have 2 times 9 minus 5. That'd be 18 minus 5, which is 13. So f of negative 3 is 13. I'm going to do 3 more. K of 3. So we'll be using the k function over here. Okay. So we got, whoops. We got 5 times 2 to the power of 3, because we're doing k of 3. I put 3 in for x. Order of operations tells me to do exponents first. So 2 to the third power is 2 times 2 times 2. That's 8. 5 times 8 is 40. Let's do f of 4. So we're using the f function again. So 2, we're putting in 4. Just write it out first and then put the 4 in there. Okay, 4 to the second power is 16. So I'm going to have 2 times 16. 2 times 16 is 32. 32 minus 5 is 27. So f of 4 is 27. Let's do h of 11 now. I'm using the h function. Okay. So, looks sloppy. Okay. So, absolute value bars, 11 for x. So I have 11 minus 5 plus 1. 11 minus 5 is 6. The absolute value of 6, remember, it's just distance away from 0, and distance is always represented positively. So the absolute value of positive 6 is still just positive 6. So 6 plus 1 gives us 7. So h of 11 equals 7. Yeah. Okay. So I'll let you evaluate the rest of the functions there. And you don't need to write this like h of -2 thing here at the end if you don't want to. Don't need to write that. Okay. Now, there we go. Now we're going to kind of look at this with tables. So there's really not much math to do. It's just kind of identifying. So A says find G of 8. Well, this is our G table, right? So G of 8. So remember, this is like our X. So when we have our input of 8 for X, what is our output? What is our output? That's what it's asking. So look at this. 8 for X, 14. This is 14. So then if I do H of 1, oh wait, what did I erase that? 14. If I do H of 1, now I'm looking at the H function. So H of 1. So remember, input, that's our X, that's our 1. We get 24. So H of 1 is 24. F of 2, so now we're looking at the F table. F of 2, there's 2 for our input, and it's 17. Not too bad, right? So I'll let you do D, E, and F. Now, this is kind of backwards for G. It says if G of X equals 5, what's the value of X? So look at this. If G of X is 5, like right here, what is X? It's 2. It's 2. Again, it says if G of X equals 5, which is right here, what is the value of X? The value of X would be 2 there. So hopefully that makes sense. And hopefully that was enough for in terms of examples to fill out the rest. Number 3 says consider the following graph functions. Now we're going to look at the graphs, fill in the blanks. So I'm going to do A. It says f of 1. So that means I'm going to be looking at the f function. The f is that curved one. That's called a parabola. You're going to learn about that later in the year. But it says f of 1. So remember, this is like our x, right? That's our input. So what is the output when x is 1? Well, x, remember, this is our x-axis is this guy. Goes like that. So, well, here's 1, right? Underline that 30 times. What is the output on the f function when x is 1? Well, scroll up here. Here it is. Look at that. It's when it's 1, it's 1 comma 9. So the input is 9. I mean, the output's 9. When the input's 1, the output is 9. Just look at where the graph's at. So let me do C, G of 2. So remember, this is our x. So we look when x is 2, but now we're looking at the G function. So if I kind of scroll up, boom, here, it's 2 comma 4. So with the input of 2, the output is 4. Trying to think if Yeah, so hopefully that's okay. Now I'm going to show you H. Let me erase all this. I don't want to get too muddy with the work. Okay. H says G of what equals 6.5. So I'm on to this one. This is another one I want to show you. G of what equals 6.5? So the output of 6.5. Well, on the G graph, output of 6.5, like 6.5 is right here on our y-axis. So I'm going to kind of scroll over here. Well, this point, when the output is 6.5, scroll down, 7. G of 7 is 6.5. I hope that's okay. Hope that's enough. Moving on to the word problems. Okay. I'm going to do, now these are all about interpretations. You're going to do the evaluating and all that good stuff, but it's a little bit about the interpretation. So I'm going to show you, so like number 4, I'm going to let you do. It's basically we got mileage and we got W for weeks. So you're basically going to substitute this in for W, and then you're just going to kind of interpret it. Now let me show you number 5. It says the formula for an area of a circle is given by the function A of R equals pi times radius squared, where R is the radius of the circle. Find A of 4, round to the nearest 100. Okay. So I'm going to plug in for R. So I have pi 4 squared. 4 squared is 16. So I'm going to do 16 times pi. And I'm going to use, you can use 3.14 for pi. I'm just going to use the pi button on the calculator to get as close to an exact answer as we can. So 16 times pi, I got, and it says round to the nearest 100th. So I'm going to say 50.27. Okay. Okay. So explain what A4 represents. Okay. So I'm going to say a circle with a radius of 4, because remember I was substituting that in for R, which is our radius, has an area, and there wasn't units on this. I'm just going to say a radius of 4 units, has an area of 50.27 units squared. Because remember, the units on a two-dimensional area would be to the second power. So that's how I would say this in a sentence. Let me do 6 also. You know, let me do 6 also. Okay. The population of Hannibal, Missouri was 17,312 in the year 2020. Population is growing by 3% each year. The function to determine the predicted population after X number of years is P of X equals 17,312 times 1.03 to the power of X. Okay, find P of 5. Okay, so that would be 17312, 1.03 to the power of 5. Says round to the nearest whole number. So 1.03 to the power of 5. So I'm going to write 1.03 to the power of 5. I don't know if you know the exponent button, but it's up here. I think we dealt with that earlier. But 1.03 yx5, I got about 1.15927. And I'm just going to keep that in the calculator. I'm not going to erase that. And I'm going to multiply it by the 17,312. And I got it says round to the nearest whole number. So I got 20069. Yeah. So what that represents would be P of 5. So 5 was the years past 2020. So I would say the predicted population of Hannibal, Missouri in 2025, because it's, remember, X represents the number of years beyond 2020. Predicted is 20,069. Yeah. Okay. So I'll let you do the rest.